Hey students, before you get started with this video, make sure your math notebook is open in front of you. You're going to take these notes on the right-hand side, and you can use the left-hand side for entry tasks, ed puzzle questions, or just any other notes you want to take during our class time together. So the name of this section is 3.1, Algebraic Expressions. And we actually have two learning targets, but we're just going to cover them each separately. So the first one, learning target 1, is going to be I can identify parts of an algebraic expression. Now, in order to do this, we need to know what an algebraic expression is. So that's going to be our first vocab term. An algebraic expression is just an expression. Remember, that means no equal sign. An expression, so something without an equal sign that contains numbers, operations, and symbols. Those symbols are most of the time variables, and we will define what a variable is a little bit later. So here is our vocab related to the parts of algebraic expressions. Our first one is terms. And while we're going through these definitions, I'm actually going to have an algebraic expression right here. It's going to be 2z squared plus y plus 3. And we are going to use this expression to help us define each of these vocab words. So terms, those are parts separated by an addition or subtraction symbol. So the parts that are separated by addition or subtraction symbols, those are our terms. So in this expression here, our terms would be 2z squared. That's our first term because it is separated from everything else by an addition symbol. Y would be our second term because it is also separated from everything else by addition symbols. And 3 is our last term, again, because it is separated from everything else by an addition symbol. So terms are basically taking all the pieces of our expression and writing them down separately, writing them as a list instead of connecting them with operations. Our next one is variables. Variables are letters representing unknown numbers. So sometimes when we do not know what number should go in our expression, we use a variable, we use a letter to say, hey, there's going to be a number here, we just don't know what it is yet. And those are called variables. So in this expression, our variables are z and y. Those are the two letters here that are representing unknown numbers. Next, we have coefficients. Coefficients are just numbers in front of / connected to variables. So you'll see how there's a 2 in front of our z. This 2 is called a coefficient. It is in front of, it is connected to our variable by multiplication. Okay, so because there's no symbol in between these, that means they're being multiplied together. So the 2 is our coefficient. There's also another coefficient here that's a little bit invisible. In front of the y, there's an invisible number 1 because 1 times y is still y. So its coefficient is a 1. The number in front of it is 1. And our last vocab term here, that would be constants. Constants. Constants are just basically a term with no variable. So it's a number all by itself, no variable connected to it. In this case, 3 is our only constant. So let's go ahead and do an example. Let's write an expression right here. We're going to have z squared plus 9z plus 3. This is example 1. And we are going to identify the terms, coefficients, and constants in this expression. So our terms, these are the pieces separated by addition or subtraction symbols. So our first term is z squared. Our next term would be 9z. And then our last term is 3. Again, we're basically rewriting our expression, but we're putting commas to make it a list instead of connecting our terms with addition or subtraction symbols. Coefficients, those are the numbers that are in front of our variables. Well, I see there's a 9 in front of that z, so that 9 is a coefficient. But remember, whenever we have a letter, a variable, and it doesn't look like there's a coefficient, that means there's an invisible 1 in front of it, because 1 times anything is just itself. So we also have a coefficient of 1. And last but not least, our constants. We do have a constant. The number 3 right here has no variable attached to it, so it is a constant. Now we're going to move into our second learning target for this section. So learning target 2 says, I can evaluate algebraic expressions. So first I'm going to give you the steps to do this, and then we'll do it together. We'll do some examples. So step number 1, we replace variables with their values. So when we are evaluating an expression, we're going to be given an expression, and then they'll tell us what that variable equals, what that letter equals, and we are going to replace that letter, that variable, with that value. And then step 2 is to evaluate. That just means really to solve using GEMDAS. So if you have forgotten GEMDAS, this is the perfect time for us to review it. So let's do an example. This is going to be example 2 because we did example 1 earlier. We are going to evaluate k squared plus 10 when k equals 5. So step 1, let's replace our variable with its value. So we're going to replace k with 5. Something to note about this, let's write it up here. I always prefer to replace that variable with its value in parentheses. You'll see in a little bit later why we like to do that. So now our expression is 5 squared plus 10. If I go through GEMDAS, I would see that exponents comes before addition, so that's what I do first. 5 squared means 5 times 5, which is 25. And 25 plus 10 is 35. So the value of that expression is 35. The value of the expression when k equals 5 is 35. Example 3, let's evaluate p squared over q when p equals 6, q equals 9. So again, step 1, let's replace our variables with their values in parentheses. So p is going to be 6, q is going to be 9. If I'm following GEMDAS order, first I take care of grouping. And remember, the fraction bar is a kind of grouping symbol. It tells me I should evaluate the top all the way, the bottom all the way, and then divide at the end. So let's start on the top. All I have to do is 6 squared. That means 6 times 6, which is 36. Now, since both the top and the bottom are just whole numbers, we can divide. 36 divided by 9 is 4. So the value of this expression when p is 6 and q is 9 is 4. We're going to do 2 more examples. In this one, we're going to evaluate 3x minus 14 when x equals 5. So again, let's replace the x with its value in parentheses. Now this example shows why we're going to put it in parentheses. Remember earlier I said coefficients are being multiplied by the variable. So if I didn't put parentheses there, I would just have the number 35. But that's not what it means. It means 3 times 5, and the parentheses help show us that. So now we're going to use GEMDAS. Multiplication comes before subtraction, so 3 times 5 is 15. 15 minus 14 is 1. So the value of this expression when x equals 5 is 1. And last but not least, let's evaluate 30 minus x divided by y when x equals 24 and y equals 1. So again, we're going to replace the variables with their values in parentheses. So 30 minus 24 divided by 1. In GEMDAS, division comes before subtraction, so that's what we do first. 24 divided by 1 is just 24. And 30 minus 24 is 6. So the value of this expression when x equals 24 and y equals 1 is 6.